have an equilateral triangle with side lengths of S. We're going to try and find the area of this triangle, and we're going to do this by splitting it into two 30, 60, 90 triangles, like I did right here. So doing this allows us to find the sides. So we can use the sides to find the area of the triangle because the formula is A equals 1/2 times base times height. So here we have the ratio of sides in a 30, 60, 90 triangle. So we have x, 2x, and x times the square root of 3. So right here, I pretty much did the same thing as the triangle I drew above, but I used s instead. So we have s divided by 2 as our base, and it's s divided by 2 because we divided our original triangle into two triangles. So it's half the original triangle. And then, so we have s divided by 2 times the square root of 3 as the height, because to get from the base to the height, you have to multiply by the square root of 3. So now that we have the base and the height, we can use our formula A equals 1/2 times the base times the height, but we only need to do the base and the height because s divided by 2 is already half the base. So A equals s divided by 2 times s divided by 2 times the square root of 3. You get A equals s squared divided by 4 times the square root of 3. So now we're going to do this with a real number, 6. So it's an equilateral triangle with sides of 6. So we have our governing formula, A equals s squared times the square root of 3 divided by 4. A equals 6 squared times the square root of 3 divided by 4. A equals 36 divided by 4 times the square root of 3. A equals 9 root 3. The end. Right here we have a hexagon inscribed in a circle, and the hexagon has a perimeter of 36, and we know that a hexagon has 6 sides, and since it's a regular hexagon, we can divide 36 by 6 and get that each side is 6. And basically a regular hexagon is when the hexagon has the sides are equal and the angles are equal. So if it's a regular hexagon, that means that all of the triangles right here are equilateral. So they all have a length of 6. So we can use our formula for the area of equilateral triangles to find the area of one of the triangles. So A equals s squared divided by 4 times the square root of 3. A equals 6 squared divided by 4 times the square root of 3. A equals 9 root 3. But this is only the area of one triangle, and we need the area of 6 triangles to find the area of the hexagon. So we multiply 9 times the square root of 3 times 6, and we get 54 times the square root of 3, or approximately 93.5. And so as you can see, we can check our answer by finding the area of the circle. And we know the circle has a radius of 6, and we know the circle should probably be bigger than the area of the hexagon because this hexagon is inside of the circle. So right here we find the area of the circle. A equals pi r squared. A equals 36 pi, and 36 pi is approximately 113. And 113 is larger than 93.5, so we know we did something correct. The end. Here we have a circle inscribed in a hexagon with an apothem of 3. So we can see that the hexagon is split into 6 triangles, and that we can use the apothem of 3 as the height of each of these triangles. To make it easier to look at, I drew one of these triangles separately, and in this picture it does not look like an equilateral triangle, but it is because the hexagon is regular, so all the triangles inside are equilateral. So we have the apothem of 3, but we don't know the base, and to find the area of a triangle we need the base and the height. But we do know that it's a 30, 60, 90 triangle, and we know that the ratio of sides in a 30, 60, 90 triangle is 1, 2, and the square root of 3. So to get from the height to the base, we divide by the square root of 3. So we have the height here, so we're going to divide by the square root of 3 to get the base. So 3 divided by the square root of 3 is 3 divided by the square root of 3. You have to multiply by the square root of 3 over the square root of 3, and then you get 3 divided by 3 times the square root of 3. But this isn't simplified yet, so you have to divide by 3, and you get 1 root 3. So 1 root 3 is only the base, so we're not done yet. But now that we have the base and the height, we can find the area of the triangle. So we know that 3 is the height and 1 root 3 is half of the base because we split the original triangle into two 30, 60, 90s. So we know that A equals 1/2 BH, A equals 3 times 1 root 3, A equals 3 root 3, but this is only one of the triangles, and there are 6 triangles inside this hexagon. So we need to multiply by 6 to get the area of the hexagon. So 3 root 3 times 6 equals 18 root 3, or approximately 31.2. To check our work, we notice that the circle is inside of the hexagon, which means the area of the circle should probably be smaller than the area of the hexagon. So when you find the area of the circle, you get A equals pi r squared, A equals 9 pi, approximately 28.3, which is less than 31.2. The end.